Bismillahirrahmanirrahim. Sajjad Sahab has explained the overall detail. Right now we are standing at the eastern salt lake. So on the south we have the Punjab platform, and on the north we have the Potwar plateau, right? And we are within the eastern salt range. So that is just the overall location of the area. The, the this is Baghanwala formation. So a little bit about the Cambrian system or Cambrian period. That Cambrian was the time when you have this biodiversity, we start Cambrian explosion. So the people say that the climate was warming and the oxygen was becoming more enriched. And the oxygen was becoming more enriched in this Earth planet. So because of this warming in oxygen, you have the Cambrian explosion. So a lot of organisms appeared, but those organisms still don't have these hard parts. That's why most of the time in the Cambrian you have these trace fossils, right? So the hard parts are not preserved. So that was a little bit about the Cambrian. The purpose of this fieldwork is to establish sequence stratigraphy, and for sequence stratigraphy you need to understand the Walter law. What is Walter law? That the laterally adjacent sedimentary environment, with the passage of time, they will vertically build up on top of one another. That's why when you're looking at the outcrop, you have different lithologies, which is the outcome of the different depositional environment. And we have discussed, these are called facies. Facies, what are the facies? Facies is the lithological product of a sedimentary environment. And within the sedimentary environment, you have the physical processes, the chemical processes, and biological processes. Since Cambrian, the life was coming, but still the life appeared in the Cambrian explosion, but still the most of the diversification that took place in the Mesozoic time, right? So the life was not very dominant in the Cambrian time. So within the sedimentary environment, you have the physical processes, biological processes, and chemical processes, and these will be preserved in the form of lithological product. So if the chemical process is dominant, you have a chemical sediments, for example evaporites. Biological activity is dominant, so you get a limestone, right? And the physical process is dominant, so you get a lithology, which is a lot of sedimentary structures. For example, this Baghanwala formation is devoid of fossils because the organisms were not very dominant in the Cambrian time. So we will be dealing with the lithological features, biological features, and chemical feature, and based on that we will be establishing depositional environment, and then Dr. Sajjad Sahab will be explaining those depositional environments in a vertical succession by arranging it in a sequence stratigraphic framework. Right now we are standing at the outcrop of the Baghanwala formation. So first of all, just tell me that why you have this bed of Tobra formation in the Baghanwala. You have Baghanwala and Tobra, and again you have Baghanwala. So ये क्या है?
Repetition of strata. What is the reason for repetition of strata?
It's a totally different depositional environment, and that was happening in the Cambrian time, right? So that is part of this Cambrian time. Yes. This is a Permian strata. So why this Permian strata is in between these Cambrian strata?
Sea level, local sea level.
It's a Permian, like एक ही टाइम है. Permian आपके पास sea level किस तरह आ गई? ऊपर भी Cambrian है, नीचे भी Cambrian है, दरमियान में you have this Permian.
सर टेक्टोनिक्स की वजह से
क्या टेक्टोनिक्स है?
कौन सी?
स्ट्रेसेस हमारे की वजह
नहीं तो क्या है stresses?
फॉल्ट का नाम नहीं सुना आपने?
It's a
Common
simple
की बात है।
fault, ठीक है? Thrust fault है, लेकिन ये इसको आप अगर वो नीचे restore करना तो ये इनके साथ मिल जाएगा. It's a thrust fault. ठीक है, यही लिथोलॉजिकल फीचर होती है आउटक्रॉप बेस पे. आप छोटी छोटी चीज़ें होती हैं, आपने उसको ऑब्जर्व करके जो है अपनी इंटरप्रिटेशन करनी है.
अच्छा, एक दूसरी बात सिंपल बोलता हूँ. If you know the facies, you can interpret the structural geology. If you do not know that this is a different facies from the lower facies and the age is different, you cannot interpret this is thrust fault.
Exactly.
First, you have to establish the stratigraphy. Then you can be able to interpret the structure.
And I'll be going into more detail that unfortunately some of the most of the structural geologists, they don't have that detailed knowledge of the biostratigraphy and these species, and that's why most of the mapping in structural geology is wrong. वो तो एक अलग बात है. So this Baghanwala formation is deposited in the intertidal setting, right? So we have discussed the tidal setting. There are three environments. You have subtidal, which is below sea level. Then you have the intertidal, which is covered during high tide and exposed during low tide. And then you have supratidal when you have high spring tide. So the water is recharged over there, and most of the time it is exposed to the subaerial conditions. So that's why most of the time you have evaporite sediments in the supratidal setting. This is intertidal setting. Okay?
What you would be expecting on top of this? कौन सी फॉर्मेशन होगी?
सुपरटाइडल के बाद
आप मैंने अभी नहीं कहा अनकन्फर्मिटी है इसके ऊपर.
बागावाला के ऊपर क्या है? परमानेंट टॉप फॉर्मेशन. ठीक. अच्छा, एक्टिव माइंड से आप करें चीज़ें ऑब्जर्व करें, क्योंकि यही चीज़ें आपको फिर फील्ड में जॉब में जो है वो होंगी, मदद आएगी. ठीक है. अब टाइड इज़ अ पीरियोडिक फिनोमेना. ठीक है. So first of all you have to look into the sediments. Is there any periodicity in the sediments? ठीक है. कोई चीज़ लिथोलॉजिस्ट जो हैं वो आपके पास जो है वो periodically you see the periodicity. Same fishes are repeating time and again because tides are coming on periodic basis.
फाइन आएंगे कभी कोर्स, फाइन कोर्स इस तरह आएंगे.
Then we discussed that the intertidal setting is comprised of three sub-environments. किसी को पता है? Intertidal setting में हमने further तीन sub-environments को delineate किया था. Number first, tidal creek. So most of the water will be going into the tidal creeks, which are channels, right? Yes. And it has a very high energy setting. So you will find channelized sandstone. ठीक है, आप outcrop पे आगे जाके जो है you will find channelized sandstone. So those representing tidal creeks. Then on sides of the tidal creeks you have a broad plain area, which is a very high energy setting, but relatively lower than the tidal creek. And that plain area is called tidal flats. ठीक है. इसी tidal flats के ऊपर आपके पास lenticular beds बनेंगे, flazer beds बनेंगे, herringbone cross stratification वो आपके पास tidal creeks में भी बन सकती है और tidal flats के ऊपर. Flazer bedding, when the dominant lithology is sand and the sand become ripply, and then the water standing on top of it is the suspended material get deposited in the trough of the ripples. So dominant lithology is sand, but you have lenses of shale, so that's called flazer bedding. And opposite of that is lenticular bedding, when the dominant lithology is shale, but you have lenticels of shale, lenticels of sand. Okay, so that's called lenticular bedding. Depending upon that what type of sediment is dominant on the tidal flat, is it sand which is dominant or shale which is dominant? So that is going to determine the flazer and lenticular bedding. And you have this herringbone cross stratification, and you have these salt soda marsh. The water come on top of it, waters get evaporated, you have these salt crystals developed, and then when another tide is coming, so that is relatively fresh. ठीक है, तो relatively fresh होगा, salinity उसकी कम होगी, so these salts will be get dissolved, and you have these hollow structures, molds left behind, and then the sediments fill these hollows, and it casts it, or आपके पास जो है the impression of the salt is left behind. ठीक है, so you have all these features. Number third environment is you have these marshes, mangroves or swamps. हमने इसको discuss किया था. ठीक है, depending upon that in which latitude of the earth planet this tide is coming. You are at low latitudes, so you have these mangroves. You are at the mid latitudes, you have the mixture of mangroves, larger trees and grasses, which are called swamps. And if you are in higher latitude, so you have these thickly vegetated grasses which are called marshes, right? Why you don't have these marshes, swamps and mangroves within the, although it's an intertidal setting, but you don't have these organic rich sediments in the form of coal or organic rich shales? आपके पास ना marshes हैं, ना swamps हैं, ना mangroves हैं. क्यों? बागावाला फॉर्मेशन के अंदर ये नहीं है। हाँ नहीं, इंटरटाइडल है ना, इंटरटाइडल में टाइडल क्रीक्स, टाइडल फ्लैट्स एंड देन यू हैव मार्शेस एंड मैंग्रोव्स, सो दैट शुड बी प्रिजर्व्ड हियर। व्हाई इट्स नॉट हियर?
फॉल राइज होता तो सर राइज
कॉमन सेंस की बात
सर
है।
इसके ऊपर कुछ डिपॉजिट नहीं हुआ है सर उनको प्रिजर्व करने के लिए।
इसके अंदर क्यों नहीं है? कैम्ब्रियन है।
सर कैम्ब्रियन में तो प्लांट इतने डेवलप नहीं है।
प्लांट्स तो डिवोनियन टाइम में आए थे।
ये पजल है, देखिए ये क्वेश्चन आएंगे आप।
Marshes, mangroves और आपके पास swamps जो हैं, these are terrestrial plants because it's a transitional marine environment and you have terrestrial plants over here. Terrestrial plants came into Devonian time, ठीक है? You have the cyanobacteria which is present in the salt range formation.
वाइट शेल आपको मिलती है।
बिल्कुल, but you don't have these plants yet evolved in the Cambrian time, that's why you don't have it, right? So just look, acha. Then you have this reddish color. So what does this reddish color represent?
environment.
जी, reddish color क्या represent करती है? Number first, oxidizing, because in Cambrian time you have a lot of oxygen is pumped into the atmosphere, so you have these subaerial conditions, a lot of oxygen. Number first, number second. नहीं, evaporates की वजह से नहीं. You have most probably feldspar in these sediments. ठीक है? और recently we have done the XRD analysis. So the clay mineralogy tells you about the climate. So if you have a cavlinite in the shale or the silt or the clay, so it represents a hot and humid climate. But if you have chlorite, aelite, phlogistonite, because these minerals represents cold and dry climate. So we have recently done the XRD analysis and we have chlorite, aelite and phlogistonite in these sediments and also feldspar. So feldspar is chemically unstable. If you found it in the sediment, so that means enough chemical weathering has not happened, and for enough chemical weathering you need high temperature and a lot of water. So that means you don't have high temperature, you don't have a lot of water, so it's a cold and dry climate. Okay, this time that's why आपके पास you have these reddish things. So थोड़ा सा आप जो है walk करें, इस चीज़ों को observe करें, you see the periodicity, pleasure belts भी इसके अंदर हैं, lenticular belts भी हैं, salsodomars भी हैं, tidal creeks के अंदर आपके पास channelized sandstone भी हैं, ठीक है? तो इसको अच्छा, ये एक बात. दूसरी बात जो सर ने बताई, Permian आपके पास this boundary is in unconformity. Huge Paleozoic part of the Paleozoic is missing. Some people say that these are the tillite beds. Some people say that this is debris flow because both environments deposits the unsorted, uncertified material. So this unsorted, uncertified material is called diamectite. Okay? But when you say diamectite, you cannot differentiate that whether it is deposited by debris flow or glacial. But if you say tillite, so that means it is deposited by glacial. The difference between the tillite and debris flow diamectite is that you have relatively rounding in the debris flow deposit because you have some fluid action involved which rounded off the edges and corners of the sediments. And secondly, you have the inverse grading. हमने डिस्कस किया था जब आपके पास debris flow में clay, pebbles, cobbles, boulders mix होके और water नीचे जाते हैं, ठीक है? तो आपके पास the final material sieves down, ठीक है? जब it sieves down, then you have these clay. The clay, due to positive buoyancy, push the larger particle upward. So you have this separation of particles. You have finer particle at the base, coarser at the top. It's called inverse grading, so that's typical of the debris flow. इसमें अगर आप देखेंगे ना आगे जाएंगे तो this inverse grading is very dominant. देखें नीचे आपके पास पिबली है, लेकिन ऊपर जाए तो आहिस्ता आहिस्ता आपके पास coastal sediments हैं. So you see some type of the inverse grading. So that's why some people say that these are debris flow deposits. Some people say that no, these are the glacial deposits and these are glacial tillite. ठीक है? इसके ऊपर आपके पास जो है डंडोत फॉर्मेशन है, ठीक है? डंडोत फॉर्मेशन here it's massive sandstone, it's a massive marine sandstone. But when you extended to the central salt range, it becomes tidal flat. So that means you have a marine environment in the eastern salt range, and then you have the relatively uplifted area, you have the tidal setting in the central salt range, and then it pinches in the western, towards the western salt range, because that whole area was uplifted, and you have the deposition of Tobra formation directly on the salt range formation. So इसीलिए आपके पास Paleozoic में this shelf was tilted to the east, और फिर आहिस्ता आहिस्ता late Paleozoic में और आपके पास Mesozoic में that was tilted to the west, and that's why this Mesozoic lithology is deposited, rock unit are deposited in the western salt range, but it's not deposited in the eastern salt range. Okay? So आपके पास जो है जब these glaciers were melting, so there was a transgression in the eastern salt range, and you have this bay kind of setting. So the marine environment was established in this bay kind of setting, and that bay kind of setting was entering into the tidal flare setting on the central salt range, और आपके पास western salt range जो है that was uplifted. ठीक है, तो ये आपके पास एक brief sketch, इसके अंदर जो है आप थोड़ा सा खैर 5-6 मिनट लगाएं, आगे जाएं, इसको ऑब्जर्व करें. कोई क्वेश्चन है तो इसमें आप पूछ लें जब तक आप ऑब्जर्वेशन नहीं करें.
लेंटिकुलर बेड्स को जरा देखिए.
हाँ